So how did we create that effect? Well, as before with the last tutorial I did, I'm not going to go through this step by step, but I am going to put up an annotated HIP file so that you can look through it at your leisure. But we'll go through the main points. So this is the animation. As we can see, we've got the font split into a number of pieces which then fly in and form the letters. In fact, what we're doing is starting by doing the simulation in the opposite direction, and we do that here in the font split setup node. Let's give ourselves a bit more space. So what we do here is create our font. We then reverse the normals so that they point in the right direction for shading later on. And then I'm using a for each SOP to break up the letters, because the shatter SOP really doesn't work very well in this circumstance. And the for each SOP is using a clip to split up the letters. I then unique the points to ensure each primitive is separate, project some UV coordinates onto them using a planar projection. Then I sort the primitives in the X direction, so the primitive numbers down here will be low and the ones over here will be high. And then we create a attribute which is just the primitive number divided by 2 plus 1, and that allows us to link each primitive to a frame at which it will start moving. So we create a group of the primitives which need to start moving at this frame, and we do that using this expression here. And then we add some normals, and then we use a pop network. And the pop network is instancing at each frame a point in the center of each primitive that's in this frame group. Then it orientates those particles correctly, splits them into groups according to whether they're still quite young or whether they're older, applies a force which moves sideways in this direction, and another force which forces the particles outwards in this direction, and it varies those forces according to how old the particle is using these groups here. And then we need drag in order to slow down the effect of the forces. Let's have a look, and I'll have some points there. Let's have a look and see what that's doing. Unfortunately, we've got the other simulation still showing here, but we can see the points coming off the letters here and flying off. We then set up a angular velocity on the particles which simply rotates them over time, and we use that to rotate the pieces later. And we have an interact SOP here, a pop rather, which forces the older particles apart from each other. So this is creating points with position and orientation, and this SOP here, the primitive SOP, is using that information to transform the pieces of letter that we have here. So when we select this one, we can see that we have the pieces of letter coming off and moving around. There they are. I should put the display flag back on the end there. That's better. So that's all very well. We've got some letters splitting up and moving out of the frame. We want the reverse to happen. We want the pieces of letter to come in and then form the letters. Well, we do that by a very simple trick, which is that we have a geometry ROP here in our output network, which renders out the geometry from that node we were just looking at, the split setup node, and it renders frames 1 to 200. Then back in the object network, we're bringing that information back in using this read in backwards object here. So we've got a little formula in here which reverses the frame order. We then add some velocity info, and we group the primitives according to whether or not they're moving, and we can do that using that same start frame attribute that we created in the split setup object that we were just looking at. So this is doing what we want, which is bringing in the pieces and forming the letters. We then use 3 object merge SOPs in these 3 objects here to separate out the primitives that are moving, the primitives that are stationary, and then this lot here, which are the primitives which have just stopped moving. And it's worth examining that a little more. So we start with an object merge which brings in everything. We then convert our start frame attribute so that it takes account of the fact that we reversed the simulation. And then we use a primitive SOP here to add alpha information, which changes as we compare the start frame to the current frame. If directly after, if the start frame is directly after the current frame, then alpha increases and then it decreases again as that separation gets larger. And then we delete the primitives which have a very low alpha value, so we don't need to render them. And then in our output network we have these 3 nodes here. This simply renders the moving pieces, and we can look at the objects there to do that, and it excludes everything else. This one renders the stationary and the moving primitives, but it uses a take to apply a matte shader to the moving primitives, or rather set the matte shading flag for the moving primitives so that they correctly obscure the stationary ones. And then finally we render the recently stationary object and the moving primitives, again with a matte shader applied so that they obscure the recently stationary primitives. Note that we have to use force objects here so that we can get around the fact that we don't know which of these nodes here might have a display flag on. So once we've rendered everything out, we bring it into a compositing network here. I should say, by the way, before we get into this, that there is a shader which shades the pieces differently according to which side is facing the camera. In fact, we don't really use that, but it's commented so that you can have a look. And we've applied a texture here, which is a sort of scratches texture. So in the final composite, we bring in the moving letters, moving pieces, and this is what they look like. There, we can see them. We then adjust their colour so that they become red. We then take the stationary letters and do something slightly more complicated with these. Let's get to a point in the frame where we have some. There we are. We then add some noise to the alpha channel, and we use that to create some coloured letters. It's very hard to see with a sort of scratchy effect on them. We then composite the moving letters over the stationary ones. Then we composite over a glisten effect, which I will go into in a second. And finally we composite everything over the background, and we can see a little bit better here what's happening. These are our moving pieces. These are our stationary pieces, which have a much more sort of ink-like effect. This obviously is our background, a plain colour. And this glossing here is the glistening effect, and I just want to describe how that's achieved. We take the render of those recently stationary primitives. And if you recall, we adjusted the alpha of these so that it depends on how long they've been stationary. We then take all of this and blur it, and then again we add some noise to the alpha channel, and then we give it all some color. So we get this glistening effect which fades in and out with those primitives because we rendered them with alpha that depended on how long they've been stationary. So different primitives are visible at different times. So that's how we get the final result.